Alright, for all you guys who are trying to remember all this basic chemistry, what's the difference between an element and a compound, and ionic, hydrogen, and covalent bonds? So, first of all, as we start, we're going to be talking about these little atoms. And when we look at size over time, so we can't even see these. And we're going to lead up to, in this unit, lipids and proteins. Throughout the rest of our course, we'll be able to talk about the rest of all the cells up to a human. And we've talked about this before, but we have the atomic level, so down to a little oxygen atom, and if we keep going up, we get to the molecules, organelles, cells, tissue, organ system, and finally the organism. Alright, first thing, difference between atom and matter. Atom is the actual smallest building block of matter. It consists of three things: protons, neutrons, and electrons. Whereas matter is anything that takes up space. So Adam said it was the smallest building block of matter. What is matter? Anything. So your skin, the ceiling, the table, your chair that you're sitting on, everything. Also going back to atoms, don't forget that protons are always positive, P and P. Neutrons are neutral, and electrons are negative. So, which two parts are found in the atom? Anyone? A proton and a neutron. Where's the electron found? As you see right over here, in the electron cloud. And so they can move all the way around. Alright, difference between an element and a compound. So element cannot be broken into simpler substances. We have all these on the periodic table, and we have gold, copper, and oxygen, and many more. Compounds, so down here, anyone guess what this is? So we have the silver metal and this green gas that's actually toxic. We'll find out. So a compound is a substance with any two or more elements in a fixed ratio. And so you have them, it's always like H2O. There's always two hydrogen with one oxygen. You throw that off, you're going to get a different compound. A mixture just has a whole bunch of different things in it together. So, example is salt, and that's what this is. We have our silver metal, our green-yellow poisonous gas, chlorine. Put those together, and you're going to get your nice white table salt. Pretty cool. Isotopes. And so, what is an isotope? It is the same element. So we have carbon, all the same element. They all have the same protons, that's why they're the same element. However, they can differ in the amount of neutrons, and so that is called an isotope. And so you have carbon 11, it has 5 neutrons, and you can see, and each one of them are more stable or less stable. So you can see 12 and 13 are pretty stable. And we look at this when we look at radioactive dating, like how do we know how old something is? And they're looking at the amount of carbon. And that's usually where this comes in. What elements are necessary for life? We actually require about 25. However, it's these top 4 that we're going to talk about the most. So oxygen, that's 65% of your weight, carbon, hydrogen, and nitrogen. You can see all these others. I know in class a lot of you guys were talking about iron. That's less than 0.01%. So you have all of these things. And so if you look at your vitamin pill packet, you'll see most of these on there. Now let's talk some about bonds. So we have covalent bonds. This is when they share. So if you think like co-captain, they're sharing electrons. And so you can see our molecule of water here, and hydrogen is sharing an electron with oxygen. That's happening with both of these. Aw, isn't that cute? And here's 2 nitrogen. They look like they're kissing, but they're sharing electrons. Aww. Alright, ionic bonds. And so ionic, this isn't the aww, this is more of a give and take situation. So opposite charges are attracted, And this occurs when electrons are lost or gained. Or you can think of stolen and taken. So with this, sodium has one little electron that's kind of free, and sodium is not exactly happy with that, but it's free hanging out there. Chlorine's sitting there saying, hey, I really would like another electron, because everyone wants 8 electrons. And so what happens is chlorine sees sodium and they're like, hey, I'd like to have that. Sodium's like, hey, okay, cool, whatever, take it, I don't really want it. And chlorine takes it, and that's how they become bonded. And it's the opposites attract. So I guess there's a little bit of awe. And here's show another example. So we have, again, sodium chloride. It's the most famous example. We have this one there. See, notice if I give that away, if you look at the next ring, I have 8. 1, 2, 3, 4, 5, 6, 7, 8. Wahahaha. 8 electrons. If you guys didn't get the reference, it was the count, Sesame Street. So, and then I have chlorine. It had 7. 1, 2, 3, 4, 5, 6, 7. When it gets that, it gets its 8th. It becomes a negative, and it also gets its 8th electron, which is it when it gets happy. The last one we're actually going to talk about is hydrogen bonds. And so hydrogen bonds are when a hydrogen atom is bonded to another one with a slightly negative area. Let me explain that with the picture, because I like pictures. And so this hydrogen bonds happen with hydrogen atoms. Makes sense. And what happens is hydrogen is slightly positive, and it likes these areas that are slightly negative, like nitrogen here. And so there's an attraction there. It's called a weak bond, because it's more of an attraction like, hey, I like you. Nitrogen's like, okay, cool. But they're not really bonded together. However, and this is how water sticks together, lots of these hydrogen bonds come together, and they're going to get really strong because there's so many of them. Alright, that is it with basic chemistry. Look forward to our next talk about water.